Hey 7th grade world, I'm back. Beautiful scenery for you, working markers, so we're good to go. Okay, so we have 3 problems today that all have to do with balances. And we're moving away from the money bags and pennies idea and seeing if we can generalize this to some other situations. So I have a situation that I'm going to read, and it's also on the blueprint, so you can read it for yourself. Nyla and Jayla have a snow shoveling business and they charge the same hourly rate. After a blizzard, Nyla shovels for 3 hours and also gets a $3 tip. The same day, Jayla shovels for 1 hour and also gets a $27 tip. They each make the same total amount of money. My question is, what is their hourly rate? How much were they making in each hour that they worked? So I've got a balanced situation here because I know that Nyla and Jayla need to make the same amount of money at the end. And I know how much they each made as a tip, but I don't know how much their flat hourly rate was since they were in the same business. So I'm going to start with Nyla. I don't know what she made each hour, but I know she worked 3 hours. So I can set those up just like we would set up the 3 money bags, and we don't know how much she made. Somebody in class said we could call that H, since it's just the hourly rate. And then on top of that, she made a tip. She just got $3 extra, and that's just her money to keep. And we know what it is. Then Jayla, she just worked 1 hour, so I would only have one of these H's. And someone must have been super nice because she also made a $27 tip. So worked fewer hours but made more kind of extra cash. And this is balanced out. So we want to know what is in one of those H's. So thinking back to what we did on Friday, as long as you do the same thing to both sides of the balance, you're going to keep it from tipping. So I'm looking to see what can I do on both sides. I know that there are hours on both sides. I've got 1 hour compared to 3 hours. So I know that I could take 1 hour off of each side. I'm going to do that. And I'm just going to show it by crossing it off. You could also write, like, first step would be to subtract or remove 1 hour from both sides. Now there's also just straight up money, the tip money that's on both sides. I've got $3 over here, $27 over here, so I could take up to $3 off of both sides. I'm going to go ahead and do it. I'm showing that I subtracted 3 to make it clear why I now have 24 extra dollars on Jayla's side. So if we were to rewrite this entire balance, we would say that Nyla has 2 hours and that those 2 hours need to be equal to the $24. Let's do that. Someday there will be special effects that will move through this. Not today. So we need to make sure that we have $24 total between those 2 hours. They're the same, so what 2 of something are going to give you 24? If I split 24 up into 2, I'm going to have that each one of those would have to be $12. So $12 is the hourly rate. Now if I plugged this back into the original balance, 12 plus 27 would be 39. 12 times 3 would be 36, plus 3 would be 39. And that would tell me that we have a balanced relationship. Both girls ended up making $39. So now we're going to take this into a slightly different realm. We're still thinking about balancing, but this time we don't have a context. I just have the problem 3 times, in parentheses, x plus 2, and that quantity is equal to 5x plus 2. Now looking at those x's, we can think, oh hey, that's like the money bags. Or hey, that's like the hours. It's something that we don't know, but we know how much of it there are. The tricky thing though, and what everybody was like, oh, what can we do with this, was seeing these parentheses. And so this takes us to the distributive property. The idea that if you are multiplying 2 quantities, that ends up being the same as repeated addition. So 3 times the quantity x plus 2 is really the same as doing x plus 2 added to itself 3 times. And you could go further if you wanted to put all of that together and then say that means that I have 3 x's and then I have 6 of this constant, this penny, or whatever you want to call it. You could take this and you could put it into your balance and solve, like we've been solving the other ones. But there's another way that you can show this as well, if you didn't take it all the way to this step of combining all of your terms. So I'd like to show you what that would look like. And this is problem 2. So I'm going to set up my balance, and I'm going to think about groups. So since I had 3 times x plus 2, that's really like just saying I have 3 groups of x plus 2. And I can show that. I could say I have x and 2. And I have that 3 times. So I have 3 groups of that. Then on the other side, 5x plus 2. No grouping here. It's just 5 x's. And then the 2 left over. And just to make sure we're on the same page, I'll go ahead and solve this now. So looking at it, I see that I can take 3 x's off of both sides, still keeping things balanced because I did the same thing to both sides. I can also take just 2 pennies off of both sides. So now I have that 4 needs to be equal to my 2 x's. So then how much would need to go into each x? Turns out you would need 2 to go into each x. And you could substitute that back into the original equation to check. 2 plus 2 is 4, times 3 is 12. 5 times 2 is 10, plus 2 is 12. Check. And then for the third problem of the day, we're just taking this reasoning farther. This idea of grouping and using the distributive property, which we are going to talk a lot more about the distributive property in the future. Right now we're thinking about it as these groupings. So for the third problem, we have 2 times the quantity 4x plus 1, and that's equal to 4 times the quantity x plus 2, all of that added to 2. So we have grouping on both sides. To show that on a balance, I need to think about how many groups of what do I have. So over here, I have 2 groups, and in each group, I have 4 x's and a 1. On the other side, I have 4 groups, and in each group is x plus 2. And then I have an additional 2 pennies on the side. So I'm going to do my grouping first, and then I'm going to just put my 2 pennies on the side. Now I could combine everything that was alike. I have 8x plus 2, and I have 4x plus 10. And if I were to solve this, I would need to decide, okay, what can I take off of both sides? I can take 4 x's off of both sides. And then I could take 2 off of both sides. Can't take any more off of both sides because I only have 2 here. And that's going to leave me with 4 x's and 8 pennies. And what's actually really nice about this one is you end up with like 4 equal sections, so it matches up perfectly. Each set of 2 pennies can go into an x, which tells you that x has to equal 2. I can substitute this back in. 4 times 2 is 8, plus 1 is 9. 9 times 2 is 18. 2 plus 2 is 4. 4 times 4 is 16. 16 plus 2 is 18. And so that checks out. Okay? So the new thing here is thinking about what those parentheses do. And when you're multiplying something by the inside, that means you, in this case, we can think about it as adding it multiple times. And you can use that idea of grouping to make your balance models and make it really clear exactly what you're combining and what you're putting together. Like last time, please let me know if there's anything that was confusing in addition to this, or if there's anything about this that you need a little bit more clarification on. Otherwise, you've got NWEA tomorrow, so get a good night's sleep and eat a good breakfast, and I'll see you tomorrow.